Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Assalamu alaikum wa rahmatullahi wa barakatuhu. Hope you all will be fine. I warmly welcome all of you to Science Champion. In this video, we will discuss about electrical resistance. Basically, resistance is the ability of a substance to slow down the flow of electrons. Like for example, traffic moving from 3 lanes to 1 lane. Cars move fast in 3 lanes, but when they have to merge into 1 lane, their speed slows down. Similarly, as we have discussed in the previous video, that electric current is the rate of flow of electric charge. So when the charges are moving and there is the hurdle, there is the opposition, there is the opposing force in their pathway, so that is the resistance. Look at the picture carefully. The flow of electron is the current, whereas the potential difference or voltage is the push or energy needed by these electrons to move. And resistance, it is the hurdle in their flow. Resistance is basically the opposition that a substance offers to the flow of electric current. It is represented by the uppercase letter R. The standard unit of resistance in which we measure it is the ohm, symbolized by the uppercase Greek letter omega. For example, in this diagram, look at the resistor, that is the bulb. The bulb is a resistor. The resistance of a light bulb filament is high, so a lot of heat and light are produced as the electricity forces its way through. And similarly, resistance along circuit wire is quite low. Every electrical appliance is a resistor because they resist their charges, and when they resist their charges, then they provide you the output. For example, charges resist or they stay in the light bulb to convert the electrical energy into the light energy. So every electrical appliance acts as a resistor. Your fan, your mobile phone, your bulb, these are all the resistors. They resist in the appliances. These are the charges. Basically, they are resisting in the appliances for some time and giving you the output. Here is the diagram that is showing to you the resistance. Resistance is by hand and it is stopping or opposing the charges that are flowing through the wire. Basically, that flow is the current, and resistance is indicated here with the diagram of the hand. Now we will discuss what is Ohm's law. Remember, this is amazing picture. Always this is an ampere. That ampere is the amount of current that is here, and there is the volt. Volt is basically the push that is needed by the electrons to move through the wire, and there is the ohm. Ohm is the amount of resistance that is stopping it, and volt is the amount of energy or the push to the charges for their flow. Remember one thing, Ohm's law depends on these three things like resistance, current and the voltage. When you want to measure the voltage, so you have V is equals to IR. When you want to measure resistance, you have R is equals to V over I. And when you want to measure electric current, you have the formula I is equals to V divided by R. So these are the formulas for measuring electrical current, potential difference and resistance. Ohm's law, it is the description of the relationship between current, voltage and resistance. Like we have discussed right now the three formulas. Current is proportional to voltage and inversely proportional to the resistance. Look at the first diagram, I is equals to V over R. In this, the electric current is directly proportional to the potential difference. And remember, when resistance is constant, or you may say that the temperature of the wire or the electrical appliance must be constant, because we have discussed in the previous video that temperature has direct relation with the resistance. By these you can calculate potential difference, electrical current and the resistance. There are three ways to use Ohm's law. Determine the current through a resistor, determine the voltage drop across a resistor, and then you can determine the resistance of an unknown resistor with the help of it. Here is a key for you. When you want to determine voltage, so V is on the top of the triangle, and I and R are present at the bottom or the base. So V is equals to IR. When you want to calculate I, so I is equals to V over R, and when you want to calculate R, so R is equals to V over I. Jazakallahu khairan.